Okay, so in this next one, we're going to be developing the exponential model when we're going to be doing it by hand, which means we're doing the manual calculations that need to be included into your assignment. So first thing that we're going to do is we're going to talk about where our asymptote should go. Now, I've got two options here for my asymptote. It can either go above or it can go below. Now, this is something that you'll want to be justifying as you go. So maybe I want to say that the asymptote is up here. That would mean that B is equal to 5,500, which I would be saying that we never expect you to go up. If I'm saying that that's where my asymptote is, I'm saying that my model is going to be trending like that. And prior to this, it never got past that amount. So you can do that. That's fine. You just need to talk about it. Now, your other option is to say that your asymptote goes below. So if I was going to say that my asymptote was below on this one, maybe I would choose for it to go about here. And then I would say that the trend of the data is going to look like this. Okay, so if that one there, so that'd be about 5,430. So I would say that while this person is decreasing, we expect it to plateau out. We don't expect them to continuously decrease past this amount. We're saying that we're pretty confident that they'll never get below this amount again. Okay, so the other thing that you could do is you could assume that your asymptote is at 0, but it'll make all of your numbers and graphs look really condensed, and it'll make it harder to see things. So I would suggest either going above or below and talking about it. Now, today in our example, I have started with this, so we'll go with that. So we're going to say that our asymptote then is at 5,430, meaning that our model, therefore, our model will be equal to y is equal to A, E, K, T plus 5,430. Next thing we're going to do is we're going to solve for another coordinate by using our initial values. So let t equal 0, and we're going to estimate what t is from our graph. So if I follow this trend, I'm going to say that our initial value over here, so when t is at 0, we're going to say that the trend of this line will be roughly about 5,510. So that's the intercept. Now that's another assumption. I'm assuming that because now most of you will have a value for when t is equal to 0, but because mine didn't match initially, I have to assume it. So here I'll be assuming that most of you will have that value. Okay, so substitute this value in, or this information in. Now, anything to the power of 0 is always 0, so this term is going to cancel out to be 1. So next thing I'm going to do is I'm going to take this to the other side by subtracting 5,430. Now, that's going to leave me with, what's that? 80. 80A. And then this term here will cancel out to be 1. So therefore, A is equal to 80. So therefore, my model is currently looking like this. Okay, next thing that I want to do is I want to estimate another coordinate so that I can figure out the K value. So the next thing I'm going to do is I'm going to let t equal, now I'll just pick another one. I'll pick this one. So when t is equal to 5, y is equal to, sorry, y is equal to 5, 6, 7, 8. That's okay. So now these values are going to get subbed into this model above. So 5480 is equal to 80E 5K plus 5,430. Okay, so the first thing that I'm going to do is I'm going to take this one to the other side by subtracting, which will leave me with 50 on this side is equal to 80E5. Okay, now I'm going to take the 80 across by division, meaning I'll be left with 5 over 8 is equal to E5K. Next thing I'm going to do is I'm going to take the E across by taking the natural log of 5 over 8. And that will leave me with 5K. And so now finally to find the value of K, all I have to do is divide this side by 5. So K is going to be equal to 1 over 5 ln 5 over 8. Just like that. Now I'm going to leave it in exact form so that I don't get rounding errors later on. So therefore, the exponential model that we found is y is equal to 80e 1 over 5 ln 5 over 8 t plus 5,430. Now your next step will be to plot this into Desmos. So if I go back over here to Desmos, I'm going to compare it back to my initial data. So Y2 regression score, 80 e to the power of, now I'm going to put this part in a bracket, 1 over 5 ln 5 over 8 t, oh no, sorry, not t, x2, so it relates back to that coordinate, and then plus 5,430. Okay, and so now you can see that it is saying that it's about 0.8863% accurate, and I can get a screenshot of it by coming over here and exporting that image. So I'm going to do that. I'm going to copy that image and I'm going to chuck it into this one over here. So there's my formulation of it. I'd have all the working above this image, and then I would also take a little screen grab of this part here and throw that in my document so that I can comment on that regression score that I've developed. So another thing that you might want to touch upon when you're talking about your formulation of this is you've done a lot of assumptions. We've assumed an intercept over here so that we can get when t is equal to 0. We've then taken one of these coordinates that we estimated to be in the middle, and then we've also estimated what we assume to be a reasonable asymptote. So if those things aren't reasonable in your assignment, then that's something that you'll need to talk about. Like I'm assuming we can't go below 5,430, but really we could. Yes.